All right, welcome back. This is from Math 220, lesson on partial fraction decomposition for tools and integration. This integral is example 2. We didn't get a chance to cover it in class, so we're going to explore it here. Notice here that the degree of the numerator is 2 and the degree of the denominator is 3, so they're off by 1, which is a perfect candidate for this method. Noticing also that the denominator has a common x factor. I'm going to begin by looking at how to factor the denominator and then use that structure to proceed forward. Since each of these have an x in common, I can rewrite this as 3x squared plus 4x minus 4 times x, and then I can factor this, noticing that 4 times 3 is negative 12, and the b term, the sum of the two roots, is 4, and then the two numbers that multiply to 12 but add to 4 are 6 and a negative 2. Rewriting this entire factored form would be x times x plus 6 divided by 3. The division of 3 is the result of the leading coefficient being a 3 here, so I'm dividing each of these factors by, and then I have x minus 2 over 3, and finally x plus 2, and then 3x minus 2 is a final factored form. And so now I can take the integrand here, and I'm going to use partial fraction decomposition on it. So I have x squared plus 4 over x, x plus 2, and 3x minus 2. Okay. Since each of these are linear factors, it's just a constant term on top, and that allows us to then write the following. Okay. Now multiplying out this quantity here by multiplying each of the quantities here by the product of each of these terms, you're going to get a cancel. So this one is going to cancel with this x when I multiply everything through by it, leaving these two factors. This one is going to cancel this x plus 2, leaving these two factors. And then this one will cancel this one, leaving these two factors. So the result is x squared plus 4 is equal to a times x plus 2, and then times 3x minus 2, plus b times x, and then 3x minus 2, and then plus c times x plus 2. Okay. Since these are all linear factors, the method 1 we discussed in class will be easiest to solve. So I'm going to plug in x equals 0. It's going to leave a 4 on this side. On this term here is going to leave a negative 4a. And these two terms are both 0 since the x equaling 0 will cancel everything else out there, which implies that a is equal to negative 1. Okay, if we let x equal, let's say, what, negative 2, we're going to have a negative 2 squared plus 4, so it's going to be 4 plus 4, so this is going to equal 8. And then over here, this is 0 and this is 0, so this is going to be for b, so b is going to be, or I should not say equal, it's equal to, b, this is going to be negative 2, and then negative 6 minus 2 is negative 8. So it looks like it'll be a positive, so b, this is going to be positive 16, which is going to be canceling out, so this simplifies that b is equal to a positive 1/2. And then finally, x is equal to, this will be 0 when it's a 2/3, so x is equal to 2/3. Let's see, over here we're going to have 2/3 squared plus 4 equals, this will be 0, this will be 0, so this is going to be c times 2/3 times 2/3 plus 2. Okay. All right, let's consider this. This is going to be 4 over 9 plus 36 over 9, multiplying this top and bottom by 9 to get a common denominator. And then, let's see, this is going to be equal to 2/3 c plus, let's see, this would be, what, 6 over 3? So it's going to be 8 over 3. This will be 8 over 3. All right, so simplifying this, we get 40 over 9 is equal to 2/3 c times 8/3. So getting rid of the 2/3 first, that's 3 halves. That's going to be a 20 and a 3. Okay, so that's gone. And then inverting and multiplying one more time, I get, let's see, 20 over 3 is equal to times 3 over 8. 3's cancel. That gives me C, and then 4 will go into both of these. It'll be a 5 here and a 2 there. Okay, so C is 5/2. Okay, all right, so now that we have our constants here, now we can take these values and plug them in here. So I get A is -1 over x, plus B was 1/2, 1 over x plus 2, and then C was 5/2, so plus 5/2, 1 over 3x minus 2. Okay? All right, now we're going to integrate all of these terms, dx, which is the equivalent form of this integral. And then the final result is to integrate each of these individually. And using the u sub here, u is equal to 3x minus 2, so du 1/3 du is equal to dx. So that means I'll have a factor of 1/3 out in front here. So I'm going to integrate each of these terms individually, so I get negative natural log of 1 over x plus 1/2 natural log of x plus 2 plus 1/3 times 5/2 is 5/6 natural log of 3x minus 2 plus a constant. And now I can combine all of these terms if I wanted to. This would be a product and this would be a division. Not 1 over x, silly. That should be natural log of x. It'd be 1 over x if I incorporate the negative in there. So I can simplify all of this to a single log should I choose, but I'll leave it like this for now. Okay? All right, I hope that was helpful, and I'll see you in the next video.